Good day, my dear friends. Today is the part 3. So we have in the previous part, we've built a Docker image. Now we're going to set up this Docker image in our repository, and then we're going to spawn services and load balancer to show that this image is actually working. So for us I decided to do it in 2 steps. So first step is to build up a basic infrastructure, which is VPC, Virtual Private Cloud, in Amazon that gives us IP addresses. Also it gives us a region with two parts of the region. So we need to have 2 subnets, just in case if probably one router part will go and the second part is still working. So it's the idea of redundancy, and this is how Amazon built it. So we definitely need to have one for the good redundancy purposes. We need to have more than one region, a part of the region. So there is a region like Australia A, Australia B, and the IP addresses could be 10.1.0. Whatever, and it can be 10.1.5.0 forward 24. So let's have a look at the files. Actually, it's probably easier to explain if we look at the files. So let's switch over to the files. This is our GitHub, and this is the make file. So in this make file, previously what we have done, we built an image. So we have an image in our container, in our LXC container. Okay, so this part is done. So now what we're going to do, we're going to build a base infrastructure out of the files which we have available. And this is where the source folder is. And then we are going to deploy all the Terraform files. And which Terraform files we have? If we look on the left-hand side of this repository, by the way, the link to this repository is actually in the description of this video. So what we've got here, ECR. Okay, so before we go to ECR, we've got security IAM, which is very important. So we're creating out of the prefix. The prefix is in variables. So this prefix is norm test. I decided to use this one. Region is Southeast 2. Instance type which we are not going to use here. I'm going to do it in Azure because apparently there are some headhunters that were not satisfied for me knowing only AWS. They also want to make sure that you know Azure. They think it's very much different. From the point of Terraform or Bicep, it's pretty much the same because you actually are deploying infrastructure as the code. Okay, but we definitely use the container port. This port 8000 is the port for our container application. As you remember, in Docker, we're using the port 8000. Also, next one is security. So security is for the security group because we need to have a firewall set up. We are not going to use port 22 because we're not setting up our own instance where we're going to deploy Docker, and this is what we're going to do in the next in the next set. This is AWS set, and the next set, as I said, it's going to be Azure. In Azure, if we look at temporary out of action, because I removed those files, we have instance which we're going to create in Azure. So it's going to be a bit different because Terraform for Azure has different resources sets, but very, very similar in a way. So and then we're going to run different things like provision, and it's still Linux, still Ubuntu. still use EC2 user. No, it's going to be different user actually. It's going to be Azure something user. But this is when we need the SSH key. So let's go back to where we were. So now ECR. So we're going to create a container. We're going to create a container. After we're creating container, link to this container, we're going to add into ECR URL text file. We will make this file. So we're actually storing it in a text file. So again, we're using the prefix, and we're using the prefix base ECR as SSM parameters, kind of for security, and caller identity account ID, which is going to be account ID of my AWS, so which is going to be something like 80 something, which is just around here. And all this stuff is just simply going to be stored in the file. So it's straightforward thing because it's just a repository that's required for a repository ECR registry, repository that's required for registry. We can have a look here, repositories, nothing. So it's just pressing by this create repository, it simply creates a repository for us. So same thing goes within the file, so nothing overly complicated. So we again ignoring the provision app as SSH, because this is where again we're running the Docker, and we're running the ECR from the Docker. And here I've been a bit naughty. I actually hard-coded my repository, and this is how my repository is actually going to look like, because this again it's nothing too complex. It's just sometimes it's a test system, and sometimes you want to show that some things you need to not hard code when you're in the professional environment, when you're going to work and there will be quite a lot of containers. Those things, they won't be hard coded. Okay, and that's important as well. So here you go, and that is the Docker provisioning. So this is where I actually install the Docker. In Amazon Linux it's going to be different for Azure, and so all of this is only shell files to set up that image in a Docker and run the same thing. But it's different in load balancing. So in load balancing, if we look at the temporary out of action files at the moment, we're going to add them up a little bit later. So this is the load balancer, and the load balancer is the one that actually looks at the thresholds, unhealthy thresholds. It's making sure that the interval is correct. If something is unhealthy, it's going to replace it. We're not using Lambda here at the moment because it's just a very simple example, and very you can add it at any stage. I might as well run some sort of thing and just go into the CloudWatch and Trail and have a look into and set up Lambda and do a little bit more sort of a little bit better example. But at the moment we're just doing it basic to show that you know what you're talking about, and there's no problem for you to actually set it up. And well, once you start, you can do the job. So so load balancer DNS name is the one which I'm outputting, because this is where our application is going to run. So this is output, and the reason why I didn't use this output file is because I don't want to confuse it with this output file. I could have put it in output something here, and then cat two more signs, which is like appending to the text file into the Terraform, like what I'm doing here is in the make file I am copying. So when I'm doing ECS infrastructure, I'm actually copying configuration files into source folder. Okay, so kind of straightforward, as I think. Let's have a look how it actually works in real life. I'm just going to run it. So what we need to do, and we're going to run it in how to say it, in stages. So I'm not just going to create SSH key because we don't need it for Fargate. So I'll just take it straight from here, Terraform, auto approve, and I'll probably remove auto approve. I want to approve it because, sorry about that. So because I want to make sure that we know what we're doing and we can check it. So let's have a look at it, at the xterm. So here's our xterm. Yeah, I'm going to edit, just 1 second. Okay, so this is our xterm, and this is our in fact I'm just going to lxc list. So what we've got here is running the DO control. So we're going to SSH to lxc exec. We're going to connect to that container, and we're going to go to myterra folder directory, and here we're just going to do what we copied from our file, which is Terraform init, Terraform apply. We're not doing auto apply, so let's run it. So we are initializing our Terraform. As you can see, it's going to add 23 components to add, nothing to destroy, and the repository URL it's already writing to us. It's going to be very simple. It's going to be that. Let's make it smaller so we can see our Elastic Container Repository in here. Yeah, so and another thing which I wanted to mention is that ECR and VPC, we actually haven't looked at the VPC. So let me just quickly go back to the VPC. I'll just turn off the xterm. So in the VPC we've got actually Cedar block, which we're using 10.5.0.0, and within that block we've got the region, which is our in variable southeast. We're going to make two regions, A and B, right? So one which is going to be A, subnet A, which is going to run on 10.5.0.0 with 24. So that means that the only variable is going to be that 0, the last digit, which is going to, we're giving it 254 addresses available. And this B, public subnet B, which is going to be 10.5.1.0. So that's basically simple, straightforward. This is what we actually here for. Okay, so that is done. I can turn on the our xterm. Actually, let me move it a little bit further over here on top, so we can also observe the Elastic container, because we are now going to set up from all of that. Let's have a look into xterm. So apart from all of this, we are going to make So subnets, VPC, subnet, parameter VPC, and where is the repository? Here is a repository, so will be created a parameter ECR. So, and we don't yet have any security group, and we don't have any image there yet, because we've created image, but we haven't sent it there yet. Okay, so here you go. We're making some of the IAM roles in order to roll it over for us, and basically it. So okay, so let's go to the end of it and just say yes. So Terraform can start execution. So here we go. I'll maximize this while it's working. Okay, here you go. So it's already worked, and we have got a repository which is that is our repository. Okay, so if we go to our if we're going to our AWS console, and now we reload that, public repositories. Here you go, private repositories. You can see that we actually created a repository now. So, but in this repository we've got no images, and this is where the next step is. So we've created, before we go doing anything else, let's check what we actually created. So here we can have a look at the VPC. So we actually created in Sydney one VPC. We've created two subnets, right? Two subnets. We've created in this region routing tables, and a security group somewhere we should have some security group here. So if we look at the security group, we've got the security group, which is GNOME test, anything with GNOME test which was just created. So for SSH access, as I said, we're not using it, but this security group front end, we're actually using. And it's for the VPC ID, as you can see. We're allowing port 3000. Am I blocking it? No. So we're allowing port 3000, 8000, 8080, and 80. Only 80 and 8000 we're going to use in this example. Okay. So let's move forward. And next step in our make file. So we successfully, by the way, we successfully done this part, which is we've deployed a base infrastructure, right? So now what we're doing here is push image. So this is what we need to do. So in this push image, we're going to tag my app with the repo URL, which we're going to get from that file which was created. So, and the file which was created, it's created a file which only contains this line, right? So if we're going to cat ECR, see this file dot text, ECR URL, it's going to have just that repository, nothing else. And what we're going to do is we are going to we're going to tag it. We're going to say docker tag my app. We're going to evaluate the cat minus F1, which is just a shell command. So for repo ID, and we're just going to send the repo ID and ECR get login. So we're going to get login with AWS, and there we're going to push it to our repository. So for this reason, I'm just going to run here. Okay, so I'm just going to run make I'm just going to run push image. I'm going to say make push image, and it will do all the magic for us. But before it's doing it, let's go to our repository, into the registry and public repository. Let's go in there. There is nothing here, right? And we are going to push it there now. So by making push image, we can show you actually before we actually push the image there. Oh, sorry, I already started it. I wanted to show you that we're doing it. We've got the image there, but you can see the part 3. We have completed that image in the last session. So let's have a look. Let's have a look. So we're pushing that image. It will take a little while. And as you can see, we are finally getting some problems here. So it's been doing this pushing for quite a while, maybe 10 minutes, maybe 5 minutes, and it's pushing 200 megabytes already 5 times. And that's no good for your, that's an example where we should have been. And you see, we've got an error, we couldn't push it. There are some problems within the networking, and there are some problems, and we already lost a gigabyte, which is very expensive, and it's going to be charged. So this is the problem which you definitely, that's the reason why we want to push that image from and have our repository like not an LXC like I've got it on my computer for just a tutorial, but we want to have that as an Amazon in Amazon. So that way we're not paying money for pushing from registry, from our computer to registry. See, so if I wouldn't use LXC, but I would have instead let's say a container instead of my own container, I would have some instance here in EC2. I wouldn't have to worry about paying for data, and we're only transferring 200 megabytes, but going it's taking 5 minutes and it's already lost a gigabyte. So this is why this is one of those points where you want to be very careful in making sure that your image is actually up there in Amazon. Okay, enough for making a point. Let's fix the issue. Okay, so the issue is solved. So we were able to rebuild the image and push it over across. But much better if it was in AWS, touching base to the same issue. So, okay, so the image is already in Amazon. Let's have a look. Where is that image? So it's supposed to be somewhere here. Reload. Hey, here we go. That's the latest image which we've got. As you can see, Amazon Linux 235.41 megabytes, and that's basically it. Let's go to the next step, and the next step is to set up that image into the ECR and also to run load balancer. That's the hard bit. Let's have a look how to do it. So we have to go into the make file, and it's always good to have a make file so you don't have to remember the commands, and you can always get back to basics. So we push the image, and now we're just doing the ECS infrastructure. So to do the ECS infrastructure, we have to copy the files that are in temporary directory. So as I mentioned, so here we go, we're changing into the folder, copying the files, and then we go with the auto approve, setting up load balancer and ECS as a Fargate. Let's do it. So let's go make ECS infrastructure. Here you go, and it's initializing for us because auto update, it's doing it by itself. We don't have to touch anything. It does tell us that it's still keeping the out file, so we can put everything in the out file. So what we need to do is I'll just move this a little bit while it's working. I'll just move it somewhere closer, and we're going to observe what it does. So it's creating, it was doing the task definitions. By the look of it, ECS was completed. So here you go, public registry, ECS, so Amazon ECS, we can connect from here. So we're going straight to Amazon ECS. As you can see, norm test ECS cluster has been created automatically, and here we should have some sort of tasks which hasn't been yet created. By the look of it, we're still waiting for the task group. Task group supposed to be created. Task definition is done. So image task 20, I've done a few times. So here you go. So those tasks, and if we go back to our cluster, in the tasks, they haven't been yet provisioned. So we're just waiting for that. Look, I think every single blogger is putting it on hold during this stage, because provisioning of the task group and a load balancer, it's a timely exercise. I will do the same. I'll just pause this video and come back when it's all done. And here we go. We just completed that. So we have to reload our cluster. As you can see, we've got pending on our tasks. So looking at our tasks, task groups, activation. So, and as you can see, it is pending. One is running, so they take a little time before they actually start those tasks. But we mentioned to our to see all of those two, they started to run, and they are from our image from the repository in here in our public repository. Sorry, in our private repositories, my apologies. So this is our task, which is the application. Task, application is also called task manager. Okay, so now let's go have a look into the EC2, because the load balancers, they live in EC2. So looking at the load balancer here, we ended up having a load balancer which works in HTTP 80. Only thing what we need is this DNS name. So we copy this, as that is actually our link to our website, the application. So we're going to paste it to the next. So we copied it, and now we're going to actually put it into our browser. So when we put it in our browser, voila, we have our application running. right? How do we know that which task is it? I'll tell you. So now if we run this task, because there are two tasks and they've got different IP addresses, to better understand it, so if we go, there is a link to task group, right? In here we've got two healthy tasks, and we've got in each task they've got different IP addresses. We can have a look into the IP addresses of each tasks and display it. Okay, so yeah, so this is the target group in load balancer, but our containers, they run in ECS. So we go to ECS, and those tasks that we need, they here. So if we click on this one as an example, here we've got the address. So we've got the address. Here you go. So this is where our application is running. The only thing is that this application runs on the port 8000, and because without actually specifying the port, you won't see it. But because we're actually moving it from 8000 to the other one, so let's say this is the application, and if I remove two of those tasks in my task, it's a bit confusing because this is tasks and the other ones are also tasks. So here you go. So this task runs on this IP address, and if I go and have a look at the other task, second one, it has another IP address. We can open the address here, also adding 8000. And here you go, that's the second one. But this one still has three tasks, and this one I already deleted two of them. So, and that's the reason why I didn't want to have a common database, because otherwise we would have to change the code to do that. But now, because we've got the database in there, we can see who is running where. Okie dokie. So now, if we go to our load balancer, this is gnome test ALB, right? And we reloaded, right? So reloaded, we can see that sometimes it runs on one, sometimes it runs on the other. And it's not one after another. As you can see, it's just done twice on one, twice on the other. It depends on the traffic. And this is how load balancers work. Okay, so if we kill one of those tasks, where is it? If we kill one of those tasks, then the load balancer will pick it up. And here you go, elastic container, task configurations, tasks. Here you go. So if we delete one of those tasks, the load balancer will pick it up and it will restart it, because the minimum is 2 tasks. As just a very simple example to show you, because here now, if we look at the to-do list, it will only show one of them, because the second one is actually dead and it's just now recovered, as you can see. So now we've got the cluster tasks, and if we reload it, we will see it's provisioning. So it's actually recovering now. So for some reason it's already running. I don't know why. Maybe I needed to reload it with a better yeah. Here you go. This is the load balancer. It actually starts showing only one of them. Here you go. So, and now because one of them is dead, now we've got a second one which also has 3 of them. This is why we shouldn't use internal database. But in any case, this is the example. This is a good example for you to understand and to explain to your employer how actually it works, so you can get the job, you know. Okay, so that's all good. So I reckon that we've done it. We've done it. The only thing what we didn't do, we haven't destroyed it. You know, so now since we've got it and things are running now, 2 tasks are running here, and there's and a load balance is running here as well, and in our logs you will see that it will actually saying that one of them is dead and we recovering it, etc. So here you go. So now what we left to do now is to destroy the whole thing, because you don't want what? You don't want your employer to pay double. So let's destroy it, and that's the simplest task ever with the Terraform. And this is why employees don't spend that many time going from one place to another and destroying one thing, then destroying another, and keeping everything in their heads. We've got Terraform and a make file and few other things that we've got it in order to make our life easier, make it better. Okay, so let's have a look and let's do it. So let's destroy what we made. My apologies, a little bit slow I am at the moment, but here we go. So here we go. So how to destroy it? We've made so much. Okay, it's a simple command. It's Terraform destroy. You bet. Okay. And here you go. It goes. I do have it in make file. I just wanted to do it by myself. And look at this. We're destroying 31 components. Okay, so we're saying yes. Voila, it's all done. It's all destroyed. So next time we meet at here, same place, same time. It's just I'm going to do the same thing in Azure. So our HR agents can say yes, they know everything. So they know AWS, they know Azure. So, but in reality, it's the Terraform. Terraform is doing all of those things for us and make it all for our systems consistent. We are still using Git, GitHub, we can use GitLab, depends of your work requirements. But anyway, I'm not going to wait until it all destroys it. Have a good one. See you next time. Bye.